Howdy. Let's start off with a Quake watch quickly that happened some time ago. Magnitude 3.5 northern Norway on Saturday 19th, 14 days ago. 3.5. And I thought that's very interesting. And I'm glad I still have this window open here on my phone because I tried to get information about this, so I started to Google it and I couldn't really find anything. But gladly, this is still the basically original site where you can find some information. So it happened in Lapland, nothing really occurred, but it's very deep, or rather deep. The quake hit at a shallow depth of 22.2 kilometers. To me, that's a rather deep quake in Lapland. 22.2. And then, when you scroll down, you really have to scroll down for quite a bit in order to get to the interesting things. Earthquake statistics, average number of earthquakes, magnitude 3 or higher, that's the earthquake rate at the area. 0.14 quakes per year, or 1 quake every 7.1 years. Previous quakes in the same area of this earthquake. Strongest in 29 years. The earthquake was the strongest to hit this part of Norway in over 29 years. Earlier, the last quake of equal or greater strength near the present epicenter had been a magnitude 3.7 earthquake on Sunday, January 21st. So, there has been some temperature anomaly in northern Norway and stuff like that. I have been showing you the huge crater out in the sea, offshore Norway. Maybe I have to show you again if you haven't seen that. Yeah, you would probably be surprised if you haven't ever seen that crater up there. But we have to talk about something else, because something is going on at the moment. And that is a hurricane in Finland today and yesterday evening. The stormy weather that shook Finland on Friday evening was quite exceptional. For the first time in the measurement history, hurricane readings were measured in the Finnish maritime sea or area when the wind speed at Kylmäpihlaja in Rauma was measured at 33.5 meters per second. The limit of a hurricane is 33 meters per second. Because of the storm, more than 18,000 households were without electricity after 9 in the morning on Saturday. Areas without electricity are located especially in southwestern Finland. I want you to keep in mind this place, Rauma, because we have to talk about this still, or it's part of the whole story. So that's the satellite map from yesterday, 24-hour loop. And we want to watch this area here in particular. Let's just watch this for a while, or a few times, in order for you to get a grasp of what's going on. Unfortunately, it's not possible to zoom out more in order to get a bigger picture of the whole thing. But maybe one day I figure out how to make a video with a computer. It would be much easier. I tried, but somehow it doesn't load up to the thing I wanted to show you. So, let's go still on. It happened in the evening, they said. And we are still in the afternoon. And we want to find Rauma. Rauma. right? Let me show you the hurricane, or the area where the hurricane force winds occurred. We want to watch this area as it develops. You can see how it starts to curl into itself. And then it went southeasterlywards into this direction and dissipated very quickly. Now let's try visible. Give it a second to load. And it's rather vague, it's not that very obvious. But here you can in a way see how it starts to curl into itself. And I also want to point out one other thing that is very important, because it's much bigger. It's a very simple reason. There seems to be something here pushing against all that stuff that's coming from there. Just look at the video. You will understand what I mean. In the meanwhile, I take a little sip of my coffee. See that? Something seems to deflect the clouds. And there are no mountains there, it's flat, there's nothing. But yet, nonetheless, something is pushing against what's coming. And I think this has to do something with the surface conductivity anomaly. Electrogeometeorology. What do I mean by that? For that we have to go to at least one of my papers. I will make a quick read through to part of one of them. Plate tectonic issues, the influence of electricity in rock forming process and in the coherent connection between science, mythology and history of Finland, part 2. And then we want to go to chapter number 4. What implications do these findings possibly have on our modern society? Yeah, and as you can see, I talk about many things: plate tectonics, growing Earth, craters, ancient pole positions, volcanic plasma phenomena, copper, sulfur, and stuff like that. But we want to go to chapter number 4. And if you have no idea what I'm talking about, I recommend you to read at least one of the papers and watch a few of my videos in order to catch up, at least a little bit. Might take a few minutes, at least. Yeah, here in this paper I show here many Central Finland continental arc units. And in some places, this structure is called the Southern Finland conductor. I don't know if it's in this map. Central Finland. No. But anyway, already in these maps as well. Actually, these are two different maps, but they exhibit something similar. There's this structure here, and here's the coast. Which is the same thing as here. And here we are at Windy. I have to zoom out a bit. Then now let's draw it again here. Somewhat sketchy, but something like that. And actually this is coming from here, from the south, and actually it's continuing all the way up here. Why I show you that? Because there's so much more about that. We are still trying to go to the chapter number 4, but there's so much other things should be explained. Especially for so-called newcomers. If you have no idea what I'm talking about, microwave pebble, impact structures in Finland and stuff like that. Ancient South Pole, maybe, here in Finland. We are talking about the polar cusps, magnetosphere, reconnection of the polar cusps, which seems to look very similar to what we find here in Scandinavia. So did the polar cusps, these regions here, once touched the surface of the Earth and left the imprint in the surface that looks like this? And here you can see the same thing again, and here you can see where the clouds get somehow shielded when they came from Greenland. And here, Rauma, where we had hurricane. Volcanic plasma phenomena. Volcanic plasma phenomena. If you haven't seen ever one of these, check out my playlist, Volcanic Plasma Phenomena, and get amazed. But we are still trying to go to chapter number 4, microwave plasma. So, what implications do these findings possibly have on our modern society? All the findings that are talked in this paper, and many others, these findings could have great implications on certain modern technologies and the understanding of nature. One of the first things which comes to the author's mind are nuclear waste storing facilities, especially those for long terms. For example, the idea of storing nuclear waste in capsules made of copper deep underground doesn't sound very good in the author's ears. At the Olkiluoto nuclear power plant in Eurajoki, Finland, the construction of the world's first nuclear waste and storage facility is going on. Not only has the construction of the last reactor been delayed due to many problems and is still not running smoothly, it also has been very expensive. Approximately 8.5 billion euros from originally estimated 3 billion euros. The construction started in 2005, but there are still problems. Yeah, still, until this day. Remember, most people in southern Finland don't have any electricity. More or less the same people, that are building the Olkiluoto nuclear power plant, are constructing Onkamo, the nuclear waste and storage facility. The author noticed in the videos and pictures seen how there is water dripping everywhere into the caves. This alone doesn't really impress positively. The fact that they are planning to store highly radiating nuclear waste in copper barrels seems a dangerous thing to do, especially when the author, me, has witnessed what induced energy can do to rocks. Yeah, you see the plasma stone in the microwave before? Just scroll back up, read the paper, watch my videos, and you know what I mean. Posiva, the firm building and maintaining the facility Onkamo, states in their website following, quote, "The inner structure of the spent fuel disposal canister comprises a spheroidal graphite cast iron component which serves as the loading bearing component of the canister and as the fuel element placement rack. The sealed copper canister has been designed to act mainly as a corrosion barrier for the cast iron inner part, which in turn contains the fuel elements." Yeah, I just really wonder, they have figured out that we have so-called forever plastics things. So why don't they use 5 centimeters of forever plastics that last forever? Never rust, never oxide. They are just there forever. No, we are using copper. What? Anyway, the inner structure is sealed with an iron lid. The inner structure of the canister is surrounded by a 5 centimeter thick copper shell and a copper lid. In the author's opinion, the copper canister might be capable of much more than just functioning as a corrosion barrier. Yeah, we have to scroll up quickly a little bit, not too much. Let me show you something. Before microwaving, that's copper ore, this green rock here. Before microwaving. Alright, that's the color. After microwaving. It's crimson red. And copper contains very much sulfur, and sulfur burns with a blue flame. I also recreated that in a microwave. Obviously the pebble here in the picture heated up so much that the sulfur started to burn. And then despite the rather poor image quality, a plasma discharge is clearly visible. In the author's opinion, this could very well represent a skirt of fire. So, and in other words, this pebble here, this could be Earth. And the magnetron here somewhere that produces the induced energy could be, like, let's just compare where we are and what is providing all the energy. The magnetron, this could be either the sun or the whole universe. Yeah. Maybe it's the whole universe that could provide energy. And it could be too much. Even for the sun. Let alone Earth. And there is probably, no, not probably, there is all the other electromagnetic wave energies available, not only microwaves. And if microwaves already have these kind of big influences on basic rocks, so to say, yeah, what do the other energy or wave frequencies have on different materials or on the same materials? Yeah, maybe they are burying them at the exact right spot and hope that telluric currents, GICs, burn up the nuclear waste. But anyway, in order to make even a stronger point about why the author thinks that there should be an open conversation about this is the fact that Earth's magnetic field is changing and weakening. This implies that solar activity will have more and more influence on the intensity of the telluric currents. It might not need any more solar activity of a Carrington event magnitude in order to make telluric currents melt things. Because Earth's magnetic field could be about 25% weaker than it was in 1859. At the same time, the amount of dangerous material stored away all over the world gets only bigger. Other modern applications might be also much more easily affected by solar activity than they have been still, let's say, 10 years ago. Another important factor of why the things explained and shown in this paper are important to understand, recognize, further and properly investigated by professionals is weather. The SCA, the surface conductivity anomaly. The map I showed you earlier, the surface conductivity anomaly. The C-pinch structure where you can find this all over the place. There are all over the place. That's the surface conductivity anomaly. So now where did we? Yeah, somewhere here, I guess. Yes. The SCA, the surface conductivity anomaly, was discovered by the author in the research of a repetitive weather pattern. This already makes a very strong point about the relationship of geological features and weather. As Earth's magnetic field is getting weaker, magnetic imprints in Earth's crust gain more and more significance in local weather. Weather is an entirely electric phenomenon, and therefore electromagnetic phenomena in Earth's crust such as metal occurrences and their associated telluric current flows will influence the weather. Weather is an entirely electric phenomenon. Yeah, clouds are plasma. As I also tried to show to you in this picture, because here on the left side, that's one of these plasma genie in a bottle. I don't know what's the exact name, but you can see here the plasma forms this kind of beads in a row, and sometimes they are like in this shape, more elongated. And that's from the Royal Institution, British Royal Institution. And here's the same thing turned by somewhat 90 degrees or something in order to make it align with these little clouds here in the sky, which are better visible here. And then you can compare those two in between. They have very much similarities. Of course, you have the right to disagree. But I can also show you this here. That's just a cloud in the sky. And here we have plasma. And they also have very much similarities. In other words, if plasma in the glass bottle looks like the thing on the right side, then we have to assume that the thing on the left side must be plasma too. Right? Or let's say like this, if the thing on the left side isn't plasma, but it looks almost exactly the same as the thing on the right, then the thing on the right cannot be plasma. So we have, in a way, either a dilemma or very good proof for clouds being plasma. But let's go on still with the paper. Weather is an entirely electric phenomenon, and therefore electromagnetic phenomena on Earth's crust, such as metal occurrences and their associated telluric current flows, will influence the weather. As a simple rule of thumb, we can take the right-hand example of current flows. When the thumb current flow direction shows upwards, the magnetic spin is counterclockwise. When the thumb current flow direction shows downwards, we have a clockwise spin. By converting this simple rule into weather, we will notice how it correlates with high and low pressure spinning directions. A low pressure system spins always counterclockwise, and therefore a high pressure system spins always counterclockwise. Yeah, that's from the northern hemisphere. It's the other way around on the southern hemisphere. The surface conductivity anomaly is connected to the Kursk magnetic anomaly. The Kursk magnetic anomaly is the strongest magnetic anomaly on Earth. The Kursk magnetic anomaly is the largest on Earth. It was first identified in the late 18th century. The region's rocks are rich in ferrous minerals and are the subject of major mining activity. The surface that's the Kursk magnetic anomaly. And what would be very cool would be if there would be vortex rings be drawn around these pillars of energy. Because they're not just standing there. They are rotating. And because, as they said, there is ferrous materials in the ground and the stuff is there in the ground, and probably never ever can they dig all of that out there. So it will basically maintain its basic charge potential, its polarity, as long as the stuff is there in the ground. So it will maintain the spinning direction of its magnetic vortex according to its chemical composition, its polarity, charge, pH, whatever you want to call it. The more you have of the stuff in the ground, the stronger the magnetic vortex will be. And if you get a magnetic vortex that is reaching up into the sky, it will be weather. It will be expressed as weather, either a low pressure system or a high pressure system. And if we get, let's draw something else sketchy here still. If this would be our magnetosphere, let's just play with the thought, or whatever else atmospheric layers we have here. There might be areas where the pillar of that energy or magnetic spinning pillar that we have here having here from the ground, there might be a layer where it doesn't do anything. I try to erase here at this area. I try to erase that you cannot see that it doesn't do anything. But in the next layer it might do very much. As we can see somewhere, or as we can observe in the sky, you can see there's cloud forming above the ground, but between the actual ground and the bottom part of the cloud, there is nothing. And let's say a thundercloud. Everybody knows that a thundercloud has the shape of an anvil that is flat at the bottom and flat on the top. Yeah. They're trying to explain us that, yeah, there's water vapor rising up and condenses there. No, probably not. There's just energy rising. And it gets only visible at certain heights, in certain layers of the atmosphere. That's why the anvil cloud starts in mid-air and ends in mid-air. Because basically the anvil cloud could be starting from the ground up until it, I don't know, to the moon. But it doesn't. It's just there, squeezed in between certain layers of the atmosphere. If we would have a thundercloud and also at the same time noctilucent clouds, that would imply we would need some light conditions. But anyway, let's just imagine. Thundercloud, and above there would be noctilucent clouds, and just above the noctilucent clouds would be the auroras. Maybe there's just a few meters between the noctilucent clouds and the auroras. Maybe a few kilometers. Empty space, so to say, an atmospheric double layer that isn't really empty space at all. So in other words, these pillars that are representing stuff that is in the ground are reaching up to the sky. And they are spinning. Magnetic vortex direction wise. So anyway, the surface conductivity is connected to Kursk magnetic anomaly, which is connected all the way down to the Black Sea. Despite not visible in the magnetic maps, the author thinks that these structures might have dendritic patterns after all. The easiest way to see them are the valleys and rivers. The further up in the mountains you go, the finer the pattern gets. This might be important to understand because all these different things make up something very big. As explained in the mountain water paper, yeah, you have to maybe check this out too if you haven't heard about my work ever. The author sees every water vein or water body as part of Earth's electrical circuit. Water reacts very strongly with electricity, not only in the bathtub. A sudden increase of telluric currents, let's say far over what is assumed by experts to be possible today, could have large implications in many places, not only Finland. The interactions between Earth and sky could possibly be monitored much better with Langmuir measurements or something like atmospheric magnet resonances. I don't know, some nerds should probably create something in order to get a glimpse at the weather for the first time. But anyway, active volcanoes could be a good way to start because the energy fluctuations could often be also observed with bare eyes, just by looking at the clouds for comparison. The understanding of weather from an electrical rather than from a chaotic point of view has practical applications in terms of predictions. The author tries to raise awareness about this topic not only by making videos but also by trying to show the mechanisms or mechanics with the tools available. And there are not that many. Anyway, surface conductivity anomaly. Here is where the hurricane happened. And here is basically the Kursk magnetic anomaly. And this goes all the way down here. Somehow it seems to spread out to here and also to here. But it's very painstaking to figure out these things because you have to go through many different kinds of maps in order to get a picture of the whole. And here we have yet another depiction of the Kursk magnetic anomaly. Just for everybody thinking that I figured out, or like that I just make this all up. No, maybe not, because we are talking about NASA. And here you can see the red blob, that is the Kursk magnetic anomaly. And the weather happened in between these two polarities. And then we have also in the same picture, this smaller picture, where we have satellite, radar. And it's the same area that got hit. There's a reason for why I drew that line there. And I also want to point that out. The worst scenario of all is the severe frost and the windless high pressure ridge that persists in the north, and Finland has not received an Olkiluoto 3. That is the nuclear power plant unit for commercial use, says Pia Ösch, director of the Energy Supply Department of the National Security Agency. Yeah, now there's a hurricane. The investigations of how those geological imprints in Earth's mantle affect weather patterns are ongoing, and possibly new insights or thoughts will be provided in part number 3. Many things were still left out of the picture and only got touched briefly. But with this paper, the author hopes to spark interest in these topics. As a possible example of how ancient patterns are still in use today, the author would still like to challenge the open-mindedness of the reader one more time. Your open-mindedness. I know it's Halloween, but we are reading the wrong paper in order to read about Halloween. I should have read the other paper. Doesn't matter. We got first snow today. So let's continue reading. Most of the patterns used still today were seen and otherwise experienced by our ancestors. Similar stories of what happened in the past are told all over the world. Things like floods, comets, winds which carried away mountains, raining brimstones, etc., are things which should be understood within a much bigger picture. Yeah. In order to be able to draw a big picture, you need an open mind, otherwise it just doesn't fit into it. And you're stuck to the box you're sitting in. Summer is about to end here in Finland. Yeah, it ended a long time ago, but anyway. And there is a possibility of having a fierce winter ahead. This is the perfect introduction for the last little topic of this paper. The snowman. Millions of peoples made millions of snowmen over the years. Everybody basically knows how a real snowman looks like, and what it needs to be called a real or a traditional snowman. He needs a broom, a hat, a scarf, a carrot nose, buttons, a smile, and usually he's made out of 3 balls of snow. Everybody knows, but no one knows why. Why is there a scarf? Why 3 balls of snow? Why the broom? The author did some research about the topic and he came to the conclusion that no one really knows why a snowman has all those features, which is an interesting thing in itself. Let's give it a try. Let's give it a try to figure out what the snowman also could represent. First, we need to remember that the history of our solar system wasn't as peaceful as conventional cosmology tries to suggest. There were many events in the past, of which some have already been discussed earlier. Furthermore, we need to take into consideration the Saturn myth with its associated polar configuration. Earth, Mars, Venus, Saturn, and Jupiter were once perfectly aligned for a while. When this configuration fell apart, many electrical discharge events, weather is an electrical phenomena, happened, of which many stories were told. We have also laboratory experiments which reproduced what ancient people have seen in the sky. The following picture is an attempt to show certain similarities between the snowman and what other people found out about our history. Before we will take a look at the picture, we want to go through the short list below. The snowman consists of 3 snowballs, Mars, Venus, and Saturn, or a plasma instability. The red prolonged nose, Mars stamping material on Earth. The scarf. Often scarves represent aurora. The broom. It is representing a thunderbolt, lightning. The stick arms. They might represent also lightning, but also the dendritic patterns. The smile. It represents the planet Saturn. The buttons. They could represent plasma characters too. Yeah, since no one knows, I feel free to make my own guesses. So now here we have this rather wild collection of pictures in order to give a few examples of where the aspects of the snowman could have had its origin. There could be many more examples, but from these we might get a good start. Picture credits, Thunderbolts Project movie, Signs of an Alien Sky. We have Anthony Piratt, characteristics of the occurrence of a high current sea pinch as recorded in antiquity, and the aurora picture is made by myself. So now first we have to find the snowman that is here in the center of the picture. Now let's follow this. It will lead us to the auroras. Okay. That is the scarf. That is the auroras representing. Like, if you like curtains. Yeah, curtains, they have a function too. I know they can block the light and stuff like this. But curtains that are drawn onto flags, curtains that don't have a function, only visual purposes, they are usually representing the auroral display. Then we have the sticky arms, which is the dendritic pattern. We have the smile that is almost visible. And here, that's the smile. And that's Saturn. That's Mars. And in between, that's Venus. In other words, Saturn, Venus, Mars, Earth. We are looking at this direction. And what you can see here, the smile, is when you are watching straight to here and you can see the lower side of planet Saturn getting lit up by the sun. And then we have the broom. that leads us to the squatter man, basically. That's from Anthony Perret. And also the broom. We have one of those Sumerian gods holding one of these. Then we have the buttons, or even the whole snowman configuration. Also here in the Perret's paper. I highly recommend to everybody to make research and read Anthony Perret's paper. You will find it here. If you find my paper, there is the reference list. You go down there, you find all the references used in this paper. Whether the snowman topic is scientific or not. Whether the snowman topic is scientific and relevant or not. It could still function as an example of how some parts of our history seem to be forgotten whilst the forms and patterns remain. Maybe a sign of the incoherency of widely spread assumptions in diverse scientific branches taken for truth, without questioning the lack of consistency and provability. Never stop wondering and asking. Be curious. Yeah, maybe I think I'll leave it here. There would be so many other things to talk about the groundwater outbreak very close to the Olkiluoto nuclear waste plant facility, and many other interesting things. But yeah, Finland just experienced the first hurricane ever. So let me end this video with an elderly video I made, obviously, some 2 years ago almost, about solar cycle 25. And yeah, I am still not surprised that the sun is putting so much stuff out as it did, contrary to many other people that were or are still somehow surprised at how does the sun do like this? Like, you know? But I said it 2 years ago already. But anyway, just that's an elderly video. I have my old logo and stuff like that. So just have a look and listen. And see you. Bye. And let's have a quick look at solar cycle 25 if I find it. That's Noah's page. So the red line is the predicted solar cycle. The violet line is smoothed out. And obviously, we are way above the chart. It could either mean it gets shorter than predicted, or if the rise continues, we are way over average than they would have expected. So I think we can expect more from the sun in near future. Interesting. I leave it here. Thanks. Bye.